Hello friends, welcome to engineering tutorial. So today we are going to start a new topic, a new subject which is related to electrical, electronics and instrumentation engineering, basically the instrumentation engineering. So the subject is process control and instrumentation. So this is the basic introductory video where we will discuss the basic concepts and then we will move on with the in-depth analysis of each of those concepts which we are going to cover. So the first important thing is to understand what this subject is all about. What are we going to study in a short way. So process control and instrumentation, it is the you can say the combination of four different fields of electrical and instrumentation engineering, also electronics, electrical, electronics and instrumentation engineering. So those four fields are first sensors and transducers, measurement and instrumentation, the electrical and electronics measurement and instrumentation, that electrical machines, in general machines, not only electrical, other mechanisms are also used such as hydraulic, pneumatic. So all of those come into play, not just electrical, in general machines. So a little bit of mechanical engineering will also come into play, basic some concepts will come into play, and then control system. So these four fields combined together form this. Okay, so it is the grouping, amalgamation of these four fields, and these four form the important blocks, building blocks of process control and instrumentation. So how these different fields come into play, we will discuss. Okay. So process control and instrumentation. So the name itself represents what is involved here: process, control, instrumentation. So first let us discuss what is a process. So basically it is a systematic series of actions or operations which gives us an end product, an end result. Okay, so a number of operations performed either simultaneously or one after the another in any way, which takes some input or many inputs and give us one or more products, result. So that constitutes a process. Various basic examples of process we can take. First, energy generation from fuels in the power plants, be it thermal power plants or hydroelectric power plants, or in the nuclear power plants, the energy generation, that is an example of a process, and it has a lot of sub processes involved in it, which gives us this final result, which is energy. Input is fuels, output is energy. Then power transmission and distribution, the energy which is produced, the transmission of that, the distribution of that power, that is also an example of a process. The electricity that we get in our houses, so that is the end result, and the energy which is generated, the transmitting of that. So the energy is the input, the power generated is the input, and the electricity that we get in our homes, that is the end result. Then various manufacturing of products, be it our mobile phones, smartphones, or be it anything, manufacturing of any product, any electrical or electronic gadget, or simple any gadget, starting from a matchstick, toothpicks, or chairs, whatever. So the manufacturing of that from the raw materials to get the end product, that is a process. The packaging and distribution also come into play there, so that also constitutes the individual processes. Then food processing, the food processing industry, a lot of processed foods we get, starting from chips or any burgers, pizzas, whatever, the mechanized ones, okay, which are not done by the human beings directly, but with the help of machines. So a lot of mechanized food processing industries are there, which produce various processed foods. So the raw materials form the input, and the final output, which is the packaged food or drink, whatever, the beverage, juices or anything, that is the end result. So these are some of the basic examples of process. Now the main objective of process control, why do we need this? So the main objective of process control and instrumentation is to ensure that we get the output as we desire, the way we want it to be. Okay, to ensure that we get the output the way we want to be, that is the purpose, that is the job of the process control and instrumentation system. Suppose we are giving some input, let's say 2, just for a simple example, we are giving input 2 and we want an output 20. So to design such a system so that we get an output close to 20, that is the job of the process control loop. We will never get an output almost equal to 20, we will get somewhere closer to that. It can be 18, it can be 19, it can be 19.5, it can be 19.8, it can be 21, it can be 22. So we may not get the exact output, but in real processes, in real life process control systems, we never get the exact output. There will always be some error. So it is the job of the process control and instrumentation system to minimize that error, okay, to keep it as low as possible. The output which we are getting should not deviate from the desired output by a long margin. To minimize the error, to keep the actual output as much as close to the desired output, that is the job of the process control system. So you get the whole picture. Why do we need a process control system? To get an output close as much as possible to the output which we want. The actual output should be close to the desired output. Okay, so then is the process control loop. So here all these blocks, the building blocks of process control and instrumentation get involved. Okay, let us see how. So this is the block, the process block. Here we give an input and we get the output. In the old days, where there were no sensors, controllers or actuators, whatever, it was simple as that. This block was only involved. Input, we give the input, we get the output. The output may not be close to the output which we want, but that's the way it was, because there were no sensors, controllers, actuators, whatever. Okay. Now with the coming of new technologies, new sensors, microcontrollers, different types of actuating mechanisms, the concept of process control loop came into play. Now, in order to maintain the quality of the product, different industries, they employ process control systems to ensure that their product always has the same quality every time. So suppose we are giving the input to the process, this block. It can be anything. It can be a simple chemical reaction, chemical plant, or any manufacturing plant or energy generation plant, whatever, and we are getting an output. Okay, so we gave the input to the process block and we are getting the output. Now this output which this block produces, the process output, it is measured by a sensor. Okay, so that sensor, it senses the output, it measures the output and gives it to a controller block. Basically a microcontroller is used in nowadays. This controller is given with a parameter called as set point. Now set point is the output which we want. Okay, set point is the output which we want. This output is the actual one. So the controller compares the set point or the output which we want with the actual output and calculates the deviation. Okay, the actual controller block looks something like this. This is the actual output, this is the set point. So this block, it is also called as summer block in control systems. It determines the difference, which is called as the error signal. That error signal is fed to the controller, and depending on the nature of error, the magnitude of the error, the controller gives a signal to the actuator to adjust the input value. Okay, to adjust the input value so that the actual output comes close to the output which we want, that is the set point value. This is a simple explanation of a process control loop. Now each of these blocks is a vast field in itself. Actuators, process, sensor, controller, these are, you know, they are a basic, you know, the subject in itself themselves. Microprocessor, microcontroller, sensors and transducers, then actuators, which electrical machines or basic machines come into play. So this is a, you know, explanation of the process control loop in short. Now we all know that we have discussed about sensors, transducers, and also about electrical machines. There are different playlists, you can watch them, but here we will just discuss them in short. Okay, what do they do here from the point of view of process control instrumentation? So before that, we must understand what a process basically looks like. In a process, this whole block, be it anything starting from processed food manufacturing or manufacturing of any electronic gadget or anything, the input which is used to get the output which we want, which is varied or which is adjusted, that is called as the manipulated variable. Okay, it is the input which is used to get the output which we want, or which directly influences or controls the output, that is called as the manipulated variable. Then the unnecessary inputs which indirectly become a part of the process, okay, cause any fluctuations in the output, these are the unnecessary inputs, those are called as disturbances. We will discuss them with the help of examples. Now I am not going into examples, otherwise it will create some confusion. Now just understand what I am saying in terms of basic definition. Controlled variable is the output which we want, okay, the parameter which we want to control, that is the controlled variable. And also sometimes in a process we get various other byproducts of the process which we don't want, or we may use it for some other purpose, but it's not directly related to the process, it is a byproduct of the process, that is the unmeasured output. Okay, so these are the various things involved in a process. Now let us discuss each of these individual blocks in short. First, sensor and transducer. I have already discussed it many times in biomedical, in sensors, transducers. So it is an element which senses or detects any change in the input parameter or quantity for which we have installed it to measure it, and produces an output signal in the same form or in a different form. When it gives us an output in the same form, it is called as a sensor, and when generally it gives us an output in electrical form or a different form, that is called as a transducer. So you can watch the sensors and transducers playlist. There I have discussed these things in detail, so I will not go into much detail here. So basic examples are RTD, thermistor, thermocouple, which are used for measurement of temperature, Bourdon tube, bellows, which are used for force and pressure measurement. Then the controller. So the controllers, they are basically devices that take the output of the sensor, compare that output with the set point value here. They compare it with the set point value and make the necessary changes to the manipulated variable with the help of the actuator. So basically the controllers that are used nowadays, there are microcontroller. Various types of microcontroller configurations are available depending on the requirement. Suitable microcontrollers are used. PLC, SCADA, they are also used. There are various, so they are very advanced things. I am not going into detail there, we will discuss it. So the controller basically influences the manipulated variable with the help of the actuator depending on the sensor output. Then we have is the actuator. So the manipulated variable has to be changed with the help of some mechanism. Okay, so that element which changes the manipulated variable, the input variable, on the command of the microcontroller is called as the actuator. Okay, it can be mechanical mechanism, hydraulic mechanism, pneumatic mechanism, or electrical mechanism. It can also be electromechanical. So there are various combinations there. Basic examples of actuators are the machines, the basic machines. It can be hydraulic, pneumatic, or electrical. Valves are used, solenoids are used, relays are used, motors are used, ram and piston arrangements are used. They are basically used for pneumatic and hydraulic, the ram and piston arrangement. So that is the job of the actuator. So the other parameters associated with here is the input variable. So there are various inputs to the process. Now two types of inputs are there, as I said here. First is the manipulated variable, which directly controls the output variable or the controlled variable. Then the unnecessary inputs called as disturbances. So the various input variables, they are controlled or regulated, they are manipulated to give us the necessary output variable. That is why it is called as manipulated variable. Disturbance variables are not within our control. Okay, they unnecessarily affect the process. Then we have is the output variable. So the output variable which we want to control or which we desire to control, that is the control variable, and the byproducts, the which are a result of the process, that is the unmeasured output. Okay, and then we have is the set point. So the set point is the desired value of the output which we want. Okay, as I said, it is the output which we want, that is defined by the set point. So it acts as a reference, okay, for the controller to keep the output within a specified range. Now let us understand this with the help of a simple example. So we'll take the example of the packaging of any beverage or juice in the food processing industry that we have. Suppose we have a mechanism where the bottles, they are filled with, let's say, orange juice. Now you may have noticed that in all the packaged drinks, the the liquid or the drink, the beverage, it is always filled to the same level. Okay, all the bottles in a particular stack or crate, they always are filled to the same level, identical. They are identical in their, the level to which they are filled. So how does that happen? If it is done by any human being, there will always be some minor difference. Some will be filled completely to the tops, and in some cases there will be some gap left. If it is done by a human being, there will always be a margin of error. The margin of error will always be huge. But when it is done by a machine, then the drinks, they are always filled to the same level. Okay, so here the error, it is less. So how does that happen? Let us just take a simple example. So what happens is that the bottles, they are filled with a particular juice or drink, let us say orange juice. So there is a level sensor which detects the level of juice in a particular container or a particular bottle. Then it sends that signal to the controller, a microcontroller, let's say in this case. The microcontroller is fed with a set point or reference signal which gives us, which gives it the information of the level up to which each of these bottles should be filled. So depending on that, the controller adjusts the valve through which the juice flows through the bottle. So it regulates the position of the valve which adjusts the flow rate of the juice flowing into the bottle. So when the juice reaches the level which is defined by the set point, the valve stops, the flow of juice stops and it moves on. Okay, so the level sensor continuously measures the level of the juice in the bottle. As it reaches the level defined by the set point, the controller issues a signal, the control valve closes and the flow rate of the flow of juice into the bottle stops. So all these bottles are filled up to the same level with orange juice. So that is a basic example. So here the output variable which we want to control is the liquid level or the level of orange juice in the bottles. That is the controlled variable, the output variable which we want to control. That is the output controlled variable. Okay, the liquid level in the bottle is the output controlled variable, the orange juice. How we are controlling it? How are we controlling the level of orange juice in the bottle? With the help of this control valve regulating the flow rate of the juice. So the variable through which we are controlling the output, that is the level of juice in the bottle, that is the manipulated variable. So the manipulated variable in this case is the flow rate of the juice which is controlled using the control valve. That is the flow rate, the input manipulated variable. So here the control valve is the actuator. The controller can be a microcontroller. Set point or reference is the level up to which we want to fill the bottle. It can be anything. It can be in terms of centimeters or it can also be in terms of volume. So there are different parameters that we want to, or that we can decide depending on the manufacturer or the industry standards. So a level sensor in this case can be a potentiometric level sensor. It can also be a capacitive level sensor. So there are many choices. So what type of sensor is being used? That is the choice of the industry. So the level sensor detects the level of juice in the bottle, continuously measures it, sends the signal to the controller. As the juice reaches the level defined by the set point, the controller issues a signal to the control valve. The control valve closes, flow of juice to the bottle stops. So that is the basic example of a simple process control loop used in industry. Okay, so this is all about the basic concepts related to process control and instrumentation. Okay, so in the upcoming videos we'll discuss some more concepts related to it. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, instrumentation and communication engineering. Have a great day. Thank you very much.